But let's have a think about neutralization. We're going to think about this very quickly because we also want to think about calorimetry. So definition for standard enthalpy of neutralization is the enthalpy change, which is not required for AQA. So if you're AQA, you can just have a couple of mins not thinking, or get your head around it anyway, because they might decide they want to apply your knowledge to neutralization. So it'd be good if you know a little bit of extra about it. So standard enthalpy change of neutralization is the enthalpy change required when an acid and an alkali react to produce 1 mole of water under standard conditions. There's your molar amount there. Under standard conditions, enthalpy change of neutralization is the formation of 1 mole of water, a H plus and an OH minus, to produce 1 mole of water. So when an acid, H plus, and an alkali, OH minus, react together in a neutralization reaction, this general equation occurs, which we've just mentioned. Acid plus can't spell. Alkali goes to make water. No, let's go salt and water. Sorry, salt and water. Sorry, I was writing the ionic equation then, and I didn't mean to. So acid plus alkali. That's where we get our water. So it's the formation of 1 mole of water. That's my ionic equation. Go back. To find the enthalpy change of neutralization for a reaction, we can't obviously use a combustion calorimeter because that's for measuring combustion. So we need to use a neutralization calorimeter. This can also be used for other reactions as well. So it is actually more general than just neutralization reactions. To find the enthalpy change of neutralization for a reaction, we use quantities in moles given by the balanced equation. So you're going to need to follow the amounts in moles. Neutralization reactions in solution are exothermic. That means they give out energy and the overall enthalpy change is negative. Sorry, I skipped on too quickly there, is negative. Neutralization calorimetry. So this, again, like I said, you can use this as a general reaction rather than just neutralization, but it is commonly used for neutralization. One of the other ones we use it for is determining enthalpy change of solution. So of putting things into solution. So for a neutralization reaction, the enthalpy change should be measured in a different way using a calorimeter. Again, not required for AQA, but we need some similar things. We need a stirrer, a thermometer, an insulated cup. So you can just talk about it being a polystyrene cup if you want, but it needs to be insulated cup or beaker, whatever you want to call it. And then our reaction mixture is inside. But the process is very similar. We need to have a thermometer, glass beaker. If you put it in a glass beaker, then it provides support for the polystyrene cup so it doesn't fall over. Rinse a measuring cylinder with the acid, measure 25 centimeters cubed of the acid and transfer to a cup. This is if you're doing a specific reaction. Stir to make sure the acid is all one temperature and then measure the initial temperature. Then rinse another measuring cylinder of the alkali, measure 25 centimeters cubed of the alkali, add the alkali to the acid, stir and record the highest temperature reached. Then we can Q because MC delta T to determine the heat energy that is exchanged. A polystyrene cup is used because it conducts less heat than metal cups or glass, so there is less heat loss to the surroundings, and it has a lower specific heat capacity. Also, it's inert, so it's not going to react. So that's all the reasons why we would use a polystyrene cup.